We're going to solve this system using the addition method, which is also sometimes called the elimination method. And the goal here is to multiply one or both of the equations in order to end up with opposite coefficients on one of the variables, so that when I add the two equations together, one of those variables is eliminated. For example, if I had a 5y and a negative 5y, and I went to add those, that would come out to be 0, so that y would be eliminated. So I want to end up with opposite numbers on one of the variables. So for this particular problem, the quickest way to get opposites on one of the variables is to multiply the second equation by negative 2. That would make the coefficient on the x a negative 4, which is the opposite of the positive 4 that we have in the first equation. Now when we decide to multiply an equation by something, we have to remember to multiply each term, including both sides of the equation, by that number. So our first equation here is going to stay the same, that 4x plus 5y equals 3. Our second equation now will become negative 4x plus 6y equals negative 14. So now we're going to add the two equations together. 4x plus negative 4x is going to be 0. So those are eliminated. 5y plus 6y is 11y. Keep your equal sign in the same relative position. And then 3 plus negative 14 is negative 11. Now to get y by itself, we simply divide both sides by 11. So in this method, because one of the variables was eliminated, we end up with an equation that just involves one variable. So we're able to solve for that variable by dividing. Now in order to solve this system, we need to specify a value for both x and y, because our original system had both variables. So far we have found the y-coordinate to be negative 1. So now we need to go ahead and find the corresponding value of x. To do that, we can take this y equals negative 1 and plug it into either of the first two original equations. So I'll go ahead and use that first equation. We have 4x plus 5y equals 3. So I'm going to replace the y with negative 1 and solve for x. It's going to give us 4x equals 8 and then x equals 2. So our ordered pair solution to this system is the ordered pair 2, negative 1. So 2 is the x-coordinate, negative 1 is the y-coordinate. To check our answer, we could take this point and plug it into both equations to make sure that we get a true statement in both of them. So you can take a 2 and plug it in for x, negative 1 for y, in both equations, and make sure you get a true statement.